Hello students. Today we will begin with the module 3 and part 2 here, that is antenna basics here. In this particular part 2 module 3 here, we are trying to understand regarding the basic parameters of the antenna here. We try to understand the pattern, the beam area, the radiation intensity, beam efficiency, directivity, gain. Okay, these are all the what you can say that antenna parameters concerned here. And also we try to understand the antenna aperture here. Okay, what is exactly the effective height here. Okay, and we try to understand the relationship between the directivity and the effective aperture here. Okay, and also the bandwidth we try to understand here. And last but not the least here, radio communication link and antenna field. Yeah, we try to understand all the parameters related to the antennas here. Okay, the third module, part second here. So for this particular antenna basics here, you can refer the book Antenna and Wave Propagation by John D. Cross here. Okay, and also if at all you can also refer another book here, Harish and Sachidanand, Antennas and Wave Propagation here. That book also you can refer here. Okay, for the further part of the module 3 and part 2, module 4 and module 5 here. Okay, you can refer these books here. Okay, so let us begin the basic understanding of antenna here. I think clearly the statement is antenna is considered as a region. Okay, so this is nothing but here a place, or you can say a region of transition here between what here, a transmission line and a space here. Okay, okay. So what does the antenna does here? Antenna is nothing but like it radiates a certain energy here. Okay, it is going to couple certain energy here, or you can say instead of energy also you can say wave here. It can concentrate or direct whatever the electromagnetic energy we are having here in a particular direction here, or you can say that it is in the assigned direction here. Okay, there is another point here, that is antenna can be isotropic or anisotropic here. What is isotropic here is antenna, if the particular antenna it is going to generate a radiation in all the directions here, okay, equally. Okay, and it is called as isotropic antenna here. Okay, if it is going to generate at one particular direction maximum and another particular directions with minimum here or less here, then it is called as anisotropic antenna here. I think but unequal distribution of energy will be anisotropic here, equal distribution of energy will be isotropic antenna here. Okay, how exactly the antenna will be selected here? Okay, based on the application that we are going to operate here. Okay, or based on the frequency range we are in need of it, or based on the electrical or any kind of a mechanical and structural aspects here. Okay, and based on that one a particular antenna will be selected here. These may also include see what is exactly the particular antenna pattern is there, how much is the gain of the particular antenna here, or how much the particular antenna is efficient here in all the environmental conditions here, what is exactly the impedance of that particular antenna here, or how exactly the frequency characteristics will be there here, what is the shape of that particular antenna, or how much is the weight of that particular antenna or size here. Okay, whether can it be economically used by all the applicants here. Okay, how exactly it is going to look around here. So these are all the aspects are there here while selecting a particular antenna for a particular application here, right? So usually one more thing is separate antennas will be used for the transmission and reception of the signals here. Okay, which may differ in shape and size and other characteristics also here. Okay, and is not that separate antennas are used for transmission reception here. Same antenna or a single antenna can be utilized for the transmission reception also here. Okay, there are not much difference between while selecting a particular antenna as a transmitting antenna or particular antenna as a receiving antenna here. There are 2 to 3 parameters here which we need to look into carefully while selecting a transmitting antenna or particularly a receiving antenna here. whenever we try to select a particular antenna as transmitting antenna here, we try to have the high efficiency here. Okay, high efficiency and the high gain here. These two are the basic okay parameters here, which are we need to look into it when we try to select a particular antenna as a transmitting antenna here. And considered with the receiving antenna here, when we should and must have the low side lobes here, or you can say and also there should be a large signal noise to ratio here. There is SNR ratio should be large here. So these two parameters we need to look into it when we try to select a particular antenna as a receiving antenna here. Okay, right. Then whenever the antenna size could be varying from the very small millimeter of order to a few millimeters here. Okay, or you can say thousands of feet here. Now, these are the just an introduction concerned with the antenna basics here. Let us move on to quite a little definition here. The basic equation is that I'll just let you know what is this basic equation here. A radio antenna can be defined as a structure here associated with the region of transition here between the guided wave and the free space wave. Guided wave is nothing but here your transmission line. Free space is nothing but here your space here that we have discussed in initial introduction here. That is okay. So antenna is basically nothing but it is a region of transition between a guided wave and a space free space wave here. So usually this is having an equation of IL is equal to Q into V, where I is nothing but here time changing current, length L is nothing but here length of the current element, Q is charge, and V is nothing but here time change of velocity, which equals acceleration of the charge here. This is the very basic equation here when we try to understand regarding the radiation, okay, of the particular antenna that has been generated here. Radiation equation you can consider here. IL is equal to Q into V here. Now, regarding how exactly it is transmitting antenna or the receiving antenna is going to be transmitting the waves and receiving the waves. Just a figure is there here. Just you look into it here. You can see in the figure here, there is we are having a generator, or you can say source here, or you can say the transmitter here. This is nothing but here transmission lines here. Okay, guided TEM wave in one-dimensional wave it is there, right? So this is what is our guided wave here, nothing but a transmission line here, and this is what we are having. Here we have transition region of an antenna here. This particular part is nothing but a transition region of an antenna here. Okay, that is nothing but we are having a tapered section here. Remember, this is how this is this up to this point we are having a transmission line which are parallel here. After this one, it has been tapered here. This tapered part or tapered transition is nothing but here the antenna you can consider here, right? Transition region of an antenna here, and after that we are having a very free space wave here, right? Nothing but here radiation has been generated into the free space here, electric field lines here, okay, which are three-dimensional wave here, right? So this is how the transmitting antenna. Same could be the receiving antenna here. Your electric field lines will be there, or a plane wave will be there here, okay, from the free space, which is going to be received at the, what you can say that you can also say that it is the mouth of an antenna here, okay, where it will be received here in the tapered section. And then, which is nothing but here again transition region of an antenna. Receiving antenna is also having the transition region of an antenna, and then it will be guided to the whatever the receiver it is there. So whenever the wave has been guided, it is by default we can consider the transverse electromagnetic wave, that is TEM wave we can consider here. In that particular mode it will be there here. Okay, so this is how the transmitting and antenna or receiving antenna will be there here, right? So there would be a perfect reflection here if at all the particular this transmission line is been terminated, either it is open circuited or short circuited. Now in this case it is open circuited here, so there we may expect a particular wave which is going to be traveling in this particular transmission line to have the perfect reflection here. If there is a perfect reflection, there is certain leakage of current will be there. That leakage of current will lead to what we call it as an electric field lines here. That is how our wave will be converted from a plane wave to the free space wave here. Okay, Right. This is how the transmitting and receiving antenna we can explain here, right? And then we try to understand one topic or one parameter concerned with the antenna here. The very basic one is the patterns here. What is a pattern? Pattern is nothing but here graphical representation. Remember, just remember one point here: graphical representation of whatever the radiation properties are there of the particular antenna here. So that the representation itself is nothing but a pattern here, which will be in a three-dimensional view here. Like you can see in this particular figure here, three-dimensional view will be there. X-axis, Y-axis, and Z-axis is there here. Usually, you can see here. This is the pattern which has been given here. This is nothing but your major lobe here. Okay, remember major lobe here, and the side small elliptical shapes are there. So these small elliptical shapes will be represented as a side lobes here. Okay, these, and at the bottom you can see there are small again the elliptical circles are there. This is nothing but here again these are also back lobes, it is called as here. Okay, between these side lobes or whatever the back lobes is there, no, there will be having certain gap here. That gap is nothing but here can call it as a null here. Okay, right? Okay, this is the field pattern here. Field pattern you can see here. Okay, of a particular antenna here, right? This is called as a main lobe or the main beam here. Okay, these are all the side lobes, back lobes, and the null here. Field components will be there. E theta, you can consider theta as the what you can say polar angle here. Phi is nothing but here you can consider it as a azimuth angle here, right? Okay, so those are the field components theta and phi will be there here in this particular figure here. Usually the radiation pattern is determined in the far field region here, and radiation parameters or properties include your power flux density, radiation intensity, field strength, directivity, phase, or whatever the polarization we are having here. Right? This is how we can understand regarding the pattern here. Remember here we need to three patterns are available here. If at all we consider the radiation pattern with respect to the field intensity and the polarization here, theta component of the electric field if is there, then it could be represented with the function of angles of theta and phi here. If at all we consider the phi as an electric field component here, and with respect to theta and phi, we can represent as E phi theta comma phi volt per meter here. If at all I consider only the phases of these 50 fields here, okay, as a function of both the theta and phi here, we can write in terms of delta theta and delta phi here. Okay, this is how we can understand regarding